What's up, Algebra 1? Today we introduced the idea of solving either equations and or inequalities. So just a quick review for anyone that missed today's class. Equation means you're talking about something with an equal sign versus inequalities, it's more less than or greater than or equal to, stuff like that. And so there's not just one value that solves the problem, but maybe infinite numbers on one side or the other of whatever value you're getting. So I'm going to do a quick solve here. I want to use opposite operations to kind of undo the equation in order to determine what value works. So the opposite of adding would be subtracting. So if I say something plus 1 is 9, take that 1 off to make it 8. And then again, when you see two things in algebra that are against each other, that represents multiplication, and the opposite of multiplication is division. So I divided that 2 over and I get 4. If that number had been a negative, you would have divided the negative with it to be negative 4. But if you're talking about inequalities, that process is the same. However, let's just do the same type of problem, negative 2x plus 1 less than 9. There are situations that you need to know about a special rule about solving inequalities. So, for example, I may solve this first one the same way in the first step, but this part, when I divide by a negative number, you need to know that when you multiply or divide by a negative across that inequality, that sign changes directions. So it's no longer less than, but it's greater than. And that is a very important rule for solving inequalities accurately. So let's look at some of the problems that I assigned for homework. So I'm going to start with number 33, and this first part is what we call distribution. Again, when you see things against each other, that represents multiplication. So this is trying to say I have 9 times negative 7, negative 63. I also have 9 times n, which should be 9n, and that equals negative 243. So now I'm trying to look for like terms here, and I see that these two numbers are what we call like terms because they do not have a variable. But you need to know which number to move. We need to start by moving 63 because our ultimate goal is to get the variable by itself on one side. So I want only n on the left. So I want to lock in on the values on the left to move them over to the other side. So let's see, 9n equals, and then we can use a calculator if you're not confident with your work, negative 243 plus 63 gives you negative 180. Okay? And now we need to take that 9 and divide it to the other side. And negative 180 divided by 9 is negative 20. So I can always check my work by plugging in that negative 20 for the variable. So I'm going to start with 9 parenthesis negative 7 plus, and then when I get to the end, I want to substitute my value, negative 20. And if this is correct, it should give me that negative 243 in the equation, which I do. So I know that this negative 20 value for n is the correct value. So that is the process that we are working on today. Showing all the work is very important to me. It'll be very important to most of your teachers in the future. So I really want us to get to a place where you're not skipping steps and you're really showing your work as you go. So I'm going to do number 35, so you can do 34 on your own. The first thing I want to recognize is that this entire side is being divided by 3. So I'd like for that to move. So I want to do the opposite of division, multiplication. I'm going to multiply that number to the other side. Negative 3 plus n equals negative 6. And now again, my goal is to get the variable by itself. So any value on the left that's on that same side as n, I want to move it. And I want to do the opposite of subtracting 3. I want to add 3 to the other side. Sorry, I put a minus, shouldn't have plus there, plus 3. And so negative 6 plus 3 is negative 3. And now I want to really check my work to make sure that it's correct. So I'll plug it back in, starting with negative 3 plus negative 3. That gives me negative 6. And then when I go to divide that by 3, I get negative 2. So that's correct. Notice that I did not type it all in at once. There's some order of operations that I need to watch out for. I really want the top to be grouped and then divide to really see it all at once. The calculator is very specific with the order of operations. So 35 and 36 are slightly different. In 35, the entire left side is divided by 3, but really this part of the left side is divided by 2. So I really shouldn't start by multiplying because this left side is not all divided by the 2, unlike 35 was. So I will tell you the first step here, we need to add 2 over. What number divided by 2 is -6? And then I'll let you finish that problem out. Try to get the r by itself so you can tell me that final answer. We'll check your work in class. So this is where we're talking about inequalities. Inequalities are when you're talking about less than, or maybe you're talking about greater than. That little line means or equal. And so anytime I'm graphing something with that or equal, I want to make sure I use a solid point or a closed point. And anytime I'm using the other inequality that does not have that or equal, I want to start with that open dot. So I think I'm going to do 40, and you can do 39. I'm going to start with number 40. Again, this whole side is divided by 2, so I want to multiply 2 to the other side. And n minus 10 has to be less than or equal to 8. Well, now I'm trying to get the variable by itself, so I'll add 10 to the other side, and it looks like any number that is 18 or smaller, any value that's less than or equal to 18, will be a part of my solution. So, for example, I could say 10. 10 is less than 18. So I can test this by plugging it in. 10 minus 10 would be 0. And if you divide that by 4, you get 0. And that solution, 0, is less than or equal to 4. So that is a value that is correct. And there are a lot of numbers. There are infinite numbers. As long as it's less than or equal to 18, when you plug that number in, it will come out to be less than or equal to 4. So I'm going to graph that point on my number line. I want a closed 18, and that's because 18 is included in the solution or equal, but also any value that is less. So 18 or less, okay? Just to make sure that everybody is comfortable with the first step here, this is distribution. So this should be -21 minus 3a less than -36. I think I kind of changed my mind. I think I do want to work this problem out because I think this one will use that rule where you change the inequality. We didn't do that here. This one did not divide by a negative number, so that sign in the middle didn't change directions. But let's kind of continue this problem. These are like terms, and I want to get a by itself. So if you're going to move one of these numbers, let's move 21. I'm adding 21 from the left side to the right side. -3a less than -36 plus 21, that is -15. And so very important if you're trying to do well on this particular quiz coming up, what I'm about to do is very important to understand when you're trying to get these accurate. So these need to be divided. I want to divide -3 to the other side. But because you're dividing by a negative, the sign in the middle will change. A is now greater than 5. So really paying close attention to why that changed is because you're dividing by a negative number. So going back to open versus closed, this solution is only values greater than 5. So 5 is not included. It's only numbers greater than 5. Okay, so making sure we understand that it's not just 5. In fact, 5 is not in the solution. It's only numbers to the right of 5 or greater than 5 on the number line. Okay, so I'm going to leave you this one. This is for you to do. But I think I'll get you started or maybe do a lot of number 42 because I'm still kind of teaching these ideas as we go. So this is called distribution. I want to multiply 7 times 1, which is 7. 7 times -3, that's -21 with the x on it, less than 37 minus 6x. So now I want to look for like terms. Move my face up a little bit. I have like terms right here. And I really want to put those together so that I don't have, it's easier to put those together and understand if you have no solution or infinitely many when that occurs. So I'm going to start by adding 6x to the other side. 7 does not change, but negative 21 plus 6 is negative 15x, less than 37. But just like I brought the x's to the left, I need to take these constants, 7 and 37, and I want to push them in the opposite direction. Again, our goal is to get x completely alone. So subtract 7 to the other side. Negative 15x is less than 30. But here it is again. We're going to see this rule several times over the next few days, trying to make sure we are understanding when you flip it and when you don't. You're about to divide negative 15 across that inequality. So x is now greater than negative 2. So really watching for when that changes and when it doesn't. Going up to negative 2, it's not or equal, so I don't want to fill that value in, but it's all values greater than that value of negative 2. All right, so you show me this one. We'll check your work tomorrow. If you have any questions, please email me or come in early, and I'll be happy to help you out with it. Thank you so much, and I'll talk to you later.